Hello everyone, my name is S.N. Patil. In this video lecture, we will discuss the numerical differentiation topic. This is the second lecture when we estimate the first, second and third derivative of the function at the near end of the table, end of the data set. We use the Newton backward interpolation formula. We start by considering backward difference table. So this is the backward difference table. Let the equispace value of x be x0, x1, x2 with step size h and their corresponding values y0, y1, y2 and so on. We define p is equal to x minus xn divided by the h. Xn is the end of the value, that is the last value. Okay. Then the Newton backward interpolation formula is given by y means f of x is equal to yn. See, in the first video lecture, here we consider the x0, that is the first value, beginning of the table. Right now, end of the table of the x. So here their corresponding value is y suffix n plus p time backward difference, first order backward difference yn, so which is defined by the formula. Suppose we have the value y0, y1, y2. Okay. And if we want the value del y1, first forward backward difference. Backward difference means what? This is the difference in a backward direction. Okay. So here the y1 minus y0. Okay. Now plus p plus 1 divided by 2 factorial. This is the second order backward difference formula. p plus 1, p plus 2 divided by 3 factorial, third order backward difference at yn, plus p plus 1, p plus 2, p plus 3. There are 4 linear factor divided by 4 factorial and fourth order backward difference at yn. Now simplify this. P is multiplied here. Then see the first two term as it is. The third one is p is multiplied here, p square plus p. Okay, similarly here the third term, fourth term and fifth term. We simplified. The p is multiplied, p plus 1 is multiplied, p plus 2 is multiplied. These are the simplified. And we find the derivative of this equation too with respect to p. So in first term, p is not there. Its derivative is 0. Okay. So here the second term, the derivative p with respect to p is 1 into the constant term, first forward difference at yn as it is. Here third term, the derivative of the p square is 2p and here p with respect to p is 1, that is 2p plus 1 divided by 2 factorial, second backward difference, plus the derivative of the fourth term is 3p square plus 6 times p plus 2 divided by 3 factorial means 6. Third order forward difference at yn. Now plus the derivative of this fifth term, 4p cube plus 18p square plus 22p plus 6 divided by 4 factorial means 24, and fourth order backward difference at y suffix n and so on. As we know, the derivative of the y with respect to x, it can be written as dy by dp, dp by dx. The value of the derivative of the p with respect to x is 1 upon h. See here, when we differentiate this term with respect to x, so we get the 1 upon h and keep dy by dp as it is and substitute this dy by dp, this value. So we get the first derivative dy by dx is 1 upon h into the dy by dp. Okay. Now substitute the value x is equal to xn. We define p is equal to x minus xn divided by the h. So for x, we substitute the xn minus xn is 0, the p is 0. So substitute p equal to 0 in this above equation, in equation number 3. Okay. So we get the first order derivative of y at last value. near the last value is equal to 1 upon h, first forward difference plus 1 by 2, second forward difference plus 1 by 3. Okay, here the 1 by 4. See, when we put p equal to 0, then simply 6 is remaining in numerator and divide by 24. Okay, that is 6 divided 24. 6 upon 24, that is 1 by 4 plus 1 by 5, fifth difference, backward difference, and continue. The formula is very easy. The denominator is 1, 2, 3, 4 and throw plus sign. Okay, and the backward difference power is increased by 1. Okay, similarly, for second order derivative, differentiate this equation number 2 with respect to p and simplify. Then we get the 1 upon h square and the derivative of second order derivative of y with respect to p. Okay, and substitute here p is equal to 0. When we put x equal to xn, that is p is equal to 0, we get the second order derivative of y with respect to x at last point. Similarly for third order derivative and so on. Okay, let us discuss the numerical example on this topic. So we have the problem, there is a year is given and the corresponding population in 1000. The first here the question is find the rate of growth of the population in the year 1981. That is the end of the data set. Okay, this value is near the end of the data set, not last, but near the end. We use the Newton backward uh, formula. So the question is rate of growth of the population, means rate of change. That is the derivative of the year, derivative of the population with respect to year. That is dy by dx at x is equal to 1981. We use the Newton backward interpolation formula. So first we construct the backward difference table. So this is the year and the population. This is the first backward difference. So this minus this. So we get the 17.40. Then this minus this, we get 18.40. This minus this, we get the 22 minus 16. And this minus this, that is the 16.69. So see, this is the first value is x0. This is x1, x2, x3, and the last one is x4. And their corresponding values y4, y3, y2, y1, y0. Okay. So this first value is del of y4. Okay. Then its previous, this is del of y3, del of y2, del of y suffix 1. Now in second column, second order backward difference table. So this is the del square y suffix 4. This is 17.40 minus 18.40. Similarly, third order, this is the 2.76 is third order y suffix 4. And the last, this is the fourth order backward difference at y suffix 4. So we consider these values for the table. Okay. Now here, the step size h is equal to 10. The last value is C, x0, x1, x2, x3, x4. The last value is x4. And the question for the x3 is equal to 1981. Okay, and we discuss in the formulas, in the derivation, when we put x is equal to last value, then we get the p is equal to 0. But right now, this is not a last value. This is the second last value. Okay, the second last value is 1981 and the last value is 1991. Okay, so the difference is here, the minus 10 divided by 10 is equal to minus 1. In derivation, the value of the p is 0. Okay, but right now the p is -1. So we have the first order backward difference formula. Derivative of the backward difference formula is 1 upon h del at yn. Yn means what? Y suffix 4. This is the y suffix 4. Okay, the n is equal to 4. Then plus 2 times p plus 1 divided by 2, second order backward difference. 3 times p square plus 6 times p plus 2 divided by 6, third order backward difference. Plus 4 times p cube plus 18p square plus 22p plus 6 divided by 24, fourth order difference, backward difference. Okay, now in this equation, substitute p is equal to -1. Okay, the in first term p is not there. Keep this term as it is. First term is as it is. The second term, when we put p is equal to -1, that is it become -2. -2 plus 1 -1, that is -1 by 2. Similarly, here substitute the p is equal to -1. Here -1 square is 1. 3 plus 2, 5, and here -1. 5 minus 6 -1, -1 by 6. Similarly, here this is the p cube means -1 cube is -1. That is -4. 22 is -22, -26. Okay. And here 18 and plus 6, 24. That is -2 divided by 24. That is simplification is -1 by 12. Okay. So from table, the substitute the first backward difference, that is del y suffix 4, this value, and h is 10. This is the first backward difference, 17.40. Then second order backward difference, that is -1. Third order backward difference, 2.76. This is the fourth order backward difference. Now simplify this. We get 1.644083. Okay. So here this is not a last value. Here this is the previous value. So we get the p is equal to -1. So remember this. Now similarly take the same example on the backward difference formula. The question is find the first and second derivative of the function at x is equal to 1.9. Okay. So this is the end of the data set. So we use here Newton backward formula, Newton backward interpolation formula. So first we construct the table. That is x is given, their corresponding f of x. F of x means y. Okay, and we prepare the table. This first value, see, this is the x0, x1, x2, x3, x4, and x5, and their corresponding values y0, y1, y2, y3, y4, and y5. Okay, the first backward difference, okay, that is the del of y5. Del of y5 means what? Y suffix 5 means what? y5 minus y, that is difference between 4, y5 and y4 means 4 minus 2.432, that is 1.5680. Similarly, this one is difference between y4 minus y3. Okay. The next one is difference between y3 minus y2, then y2 minus y1, and last y1 minus y0. So this is the del of y1. Now second order backward difference, this is the second order backward difference y5. That is difference between these two values. Okay. Now this is the third order backward difference. Okay. 0.4320 minus 0.3840, that is 0.0480. This is the fourth order, and this is the fifth order. Okay. So here first we find the p. So this is not a last value is given. its previous value, that is 1.9. Okay, so here the step size is 0.2, h is 0.2, the x is 1.9, x is 1.9, this is the x5, step value is 0.2. Simplify 1.9 minus 2 divided by the 0.2, so we get minus 0.5. Substitute this value in the first order difference, first order derivative of the backward interpolation formula. We have discussed this formula in derivation. So substitute here, p is equal to minus 0.5. So substitute here, the second term is 0. In first term, p is not there. So we get this. Okay. And the formula of the first order y suffix 5. Here, the n is equal to 5. That is 1.5680. Okay. The second one is 0. This value is 0 when we substitute the p is equal to minus 0.5. Now this is the third order. We substitute the third order value 0.0480 and the next values are 0. So we get the 7.83. This is the first order, first derivative of the function y. Okay. Now second order, this is the formula. We have calculated this formula from the derivation. Substitute p is equal to minus 0.5 and put the values from the table. This is the second order forward difference, backward difference. So we put 0.4380 for the second order. Okay, we substitute here. Then this is the 0.05. See, this value is here. Actually, this is the 0.0. Actually, this value is round up. Plus the fourth order is 0. So we get 11.4. Okay. Through in Excel sheet, this value round up here. Okay. Okay. Thank you. These are the two examples we discuss on the Newton backward interpolation formula when we want the first, second derivative at the end of the data set, end of the table. Okay. Thank you. Thanks for the listening.